All right, so today we are continuing with example in simultaneous equation. So here we have a problem. Solve the simultaneous equation, or solve the equation rather. 3x minus 4 plus z equals 5, and 2x plus 2y plus 3z equals 4, and x plus 3y minus z equals 11. You know, one thing about simultaneous equation is that simultaneous equation is an equation which involves more than one unknown. So from two unknown and henceforth. So 2 unknown, 3 unknown, 4 unknown, etc. Now, if you want to solve a simultaneous equation, for it to be able to be solved, the number of the unknown must be equal to the number of the equation. That is, if we have two equations, of course, if we have two unknown, of course, we have two equations. All right. If we have 3 unknown, of course, we have 3 equations. So the number of the unknown must equalize with the number of the equation. Otherwise, it cannot be able to be solved. All right. Now, today we are fortunate to have a standardized simultaneous equation. What do I mean? An equation that has equal number of the unknown and number of the equation. So we have 3 unknown here, and equation is 3 equations. So it is solvable. So let's get started. All right, solution. Now I decided for the inconveniency of misinterpreting z with 2, so I chose to cross my z this way. All right, that's why I cross my z this way. So our first equation is 3x minus 4 plus z equals 5. Our second equation is 2x plus 2y plus 3z equals 4. And lastly, our third equation is x plus 3y minus z equals 11. You know, one of the techniques we employ in solving equation involving 3 unknown is that we take either two from the 3 equations. Either we pick equation 1 and 2, or equation 1 and 3, or we pick equation 2 and 1, or equation 2 and 3, or we pick equation 3 and 2, or equation 3 and 1. When we pick 2, in any case, we will eliminate one of the unknown, because there are 3 unknown. We eliminate one of the unknown by multiplying both equations by their respective, by multiplying one of the equation with the coefficient of the particular unknown we want to remove in the other equation, and also by multiplying the remaining with the coefficient of the second one. What I'm trying to say is that we have to eliminate one unknown. For instance, if you want to eliminate x here, in these 2 equations, I want to eliminate x. I will multiply equation 2 by 3, because x in equation 1 is 3, and I'll multiply equation 1 by 2, because x in equation 2 in equation 1, I'll multiply equation 2 by 3, because x in equation 1 is 3. So what I'm trying to say in essence is that for you to be able to eliminate any unknown, you have to make them to have the same coefficient. So if they have the same coefficient, they will subtract each other and they will vanish, right? But we are not applying it totally here, because one of the equation does not have the 3 unknown. So one of the equation have x and y. All right. So because I have x and y, x and z. So we already have 2 unknown here. Our target is to use this equation, eliminate y, so that we can have x and z. So if we can be able to have 2 unknown, having 2 equations with 2 unknown, we can be able to solve it the usual way of solving simultaneous equation. All right. So that is the wisdom. Now, supposing that this thing is not up to 3, so if we pick these 2, we eliminate one particular unknown, let me say y, and we pick another 2, maybe that's one of these plus the third one, we also delete the same unknown, then we'll have 2 unknown in each case, and that 2 unknown in each case, we'll be able to solve it the normal way we are solving 2 unknown. And when we get the result of the 2 unknown, we will replace their value in one of the equations that has the 3 unknown, so we can be able to find the remaining unknown. That is the wisdom we use in solving this. So we are not using the usual method, because we already have 2 unknown in one of the equations, so we only have x and z, so we can use these to find another x and z, then solve it with this, solve for x and z, then we come back and find y. All right. So now, obviously, we don't need to decide the one to eliminate right now for easier solving. So we are mandated to eliminate y, because we already have x and z. So if we can eliminate y, we have x and z Then with the x and z, we can use to solve this x and z simultaneously as two unknown. We can get the value of x and z, and then we can replace the value of x and z in any of the equations, either 2 or 3, so we can be able to find y. Now, to eliminate y in these two equations, we will multiply equation 3 by the coefficient of y in equation 2, which is 2. So if I times 3 here by these 2, it will become 6. And we'll multiply equation 2 by the coefficient of y in equation 3, which is 3. So if we multiply here by 3, we have 6. So we have 6, 6 in each case. So if I have 6, 6 in this case, we can be able to subtract one equation from the other. Alright, so if we do that, we have eliminated y. We end up having the terms in x and what? Z. So we now say multiply equation 2, which is this one, by the coefficient of y in equation 3, which is 3. So multiply equation 2 by 3. So the wisdom behind this 3 is the coefficient of y in equation 3. Then multiply equation 3 by the coefficient of y in equation 2, which is 2. So multiply equation 3 by 2. Alright? So by so doing, our equation 3, which is x plus 3y, plus 3y minus z, we'll multiply it by 3. Alright? Multiply it by 3. Sorry. We started with equation 2, sorry. So we are going to start with equation 2. So our equation 2, 2x plus 2y plus 3z equals 4. So here we have 2x plus 2y plus 3z equals 4. So we multiply both sides by what? By what? 3. So here times 3, and here, which is 4 times 3. So that's how we have 3 into this and 3 into this. So if 3 times 2x, we have 6x. 3 times 2, we have 6y. And 3 times 3z, we have 9z. Because 3 times 2 is 6, 3 times 2 is 6, 3 times 3 is 9. So, and 3 times 4 is 12. Alright, so we are multiplying equation 3 by the coefficient of y in equation 2, which is 2. So if we do that, we have 2 into x plus 3y minus z equals 11. So 2 we times here, which is this, and 2 we times 11, which is this. So 2 times 2x is 2x. 2 times x is 2x. 2 times 3y. 2 times 3 is 6. We have y. Of course, plus minus is minus. 2 times z is 2z. Alright? And finally, 2 times 11 is 20. So with that, somebody asks, how do we got equation 4 and equation 3? We already have equation 3 here. So our next equation is supposed to be equation 4. Now remember that equation 4 is a multiple of equation 2. Yes. It is equation 2. Equation 4 is equation 2. Multiply itself how many times? 3 times. Because we multiply equation 2 by 3, then we now have equation 4. Okay? And also equation 5 is also a multiple of equation 3, because we multiply equation 3 by what? By 2. By 2, then we now have equation 5. So bear it in mind that equation 4 and 5 are the respective multiple of equation 2 and 3. Alright? So bear it in mind. So both of them are the same with this, just that they are multiple. Okay, now, so we have gotten our target. Our target is that we make y to have the same coefficient in both equations 4 and 5. So we have gotten y as 6, having a coefficient of 6, and we have gotten y here having a coefficient of 6. So in that case, we can subtract any of the equation. Okay, here we will choose to subtract the bigger one from the smaller one. When you look at this, the terms, in terms of the terms, we have bigger terms here. Alright? It's true that 22 is bigger than 12, but we have bigger terms here. So we can say subtract equation 5 from equation 4. So subtract equation 5 from equation 4. So if we are subtracting equation 5 from 4, we will start with 4, because it's 4 that we are subtracting from. So our equation 4 here is 6x plus 6y plus 9z equals to 12, minus our equation 5 is 2x plus 6y minus 2z equals 22. So if we subtract, 6x minus 2x is 4x. Minus plus is minus. 6y minus 6y is 0. So that is why we do this subtraction. So this is plus 0. Minus minus is plus. 9z plus 2z is plus 11z. Alright? because minus minus is plus. All right, so this is 9z minus minus 2z. So minus minus is plus. So this is 9z plus 2z, which is 11z plus 11z. So 12 minus 22 is minus 10. So if we simplify this further, we have 4x plus 0 is nothing, then plus 11z equals minus 10. So at this point, we have developed a new equation. So we can call this, we already have 5 equations, so the next should be equation 6. Now, we are going to bring in equation 1 in this situation. Equation 1, we have 3x and z. So from equation 1, we have that 3x minus 4 plus z equals 5. So let's rearrange. We can add 4 to both sides. So if we add 4 to both sides, we have 3x minus 4 plus z plus 4 equals 5 plus 4. Now the question is, why am I adding 4? I want to simplify this in such a way that there won't be any normal number here. The only thing we have here, the term we have here is x and z. So I want to eliminate this minus 4. And the only way to eliminate it is to add 4 to both sides. Alright, so if I do that, because it takes plus 4 to cancel out with minus 4. Alright, some people will say that minus 4 will cross over and become plus 4 here. The point is, nothing is crossing over. It's just that the process of removing minus 4 here will make it to be plus 4 here. Because it takes plus 4 to remove minus 4. And remember, in the rules of equation, anything you do to one side, do it to the other side. So if I add 4 here to remove minus 4, I will equally add 4 here to maintain the equality, okay? Yeah, so at the end of the day, this minus 4 will appear to be plus 4 here. So at the end of the day, we are left with 3x plus z equals 5 plus 4 is 9. Okay? So at the end, we can call this our equation 7. Remember, equation 7 is the rearrangement of equation 1. Now, somebody will say, why did I call it equation 7? Of course, we already have equation 6, so the next will be 7. The next will be 8, and so forth. Alright, now we are going to consider equation 6 and 7 because they have what we need, x and z. Now in the equation, we will choose the one to eliminate. If we choose x, that means we'll multiply here by 4 and multiply here by 3. So multiply, we have 4 times 3 and 3 times 4. So we have 12, alright? But it's more easier to eliminate z here because we don't need to multiply any number to both sides, just 1. Because here we already have 1, coefficient 1, here is 11. So we can easily multiply this one by 11. We can have a coefficient of 11 here. So we can be able to eliminate z. You know, remember, for you to eliminate any term, you have to make their coefficient equal so that they will cancel each other, either by subtraction or by addition, depending on their sign, all right? So we multiply equation 7 by 11. So if we do that, so multiply equation 7 by 11. So if we have 11 into 3x plus z equals to 11 times 9. So multiply both sides by 11. If we open bracket, 11 times 3 is 33. So 33x plus 11 times z, 11z equals 11 times 9 is 9. So here we have equation 8. Now we have succeeded in making 11 here to have a coefficient of 11. So now they have the same coefficient. So we're now comparing equation 6 and equation 8. Remember, equation 8 is a multiple of equation 11. That is 11 times equation 7 will give you equation 8, right? So we are now comparing equation 8 and equation 6. So here we will subtract because they have the same sign, all right? If they have opposite sign, we add, they will cancel. If we subtract, one will subtract each other. So let's subtract the smaller one from the bigger one. So this is to be smaller one. So we subtract equation 6 from equation 8. So here subtract equation 6 from equation 8. So if we do that, we now have that we start from 8, the one from, so we have 33x plus 11z equals 99 minus, you have 4x plus 11z equals to minus 10. Okay, So 33x minus 4x should be 28, okay, 29x. 33x minus 4x is 29x. 3 will cancel, remaining 1x, remaining 30x here. So 30x minus 1x is 29x. So minus 11z plus 11z, sorry, plus 11z minus, because minus plus is minus. So 11z minus 11z is 0. That's why we subtracted, right? So which is equals to, here we have minus, you're not subtracting the equal sign, you're just bringing it down, okay? Or we can say plus 0 here, is alright, equals, minus is plus, 99 plus 10 should be 109. Of course, we are left with 29x, plus 0 is nothing, 29x equals to 109. So plus 0 is nothing, so we can ignore it. At this point, we divide both sides by 29, so we have a 29x over 29 equals 109 over 29. So 29 cancels 29, so therefore our x is 109 over 29. So we have gotten our x, so the next one is to find y. So let's find y here. Let's find y here. So, to find y here, we use, in fact, we use any equation that involves x and z, alright? X and z. So let's look for the simplest equation that involves x and z. Of course, I saw one here, so we can use this one, okay? We can use this one, 3x plus z equals 9. So here, so using equation 7 to find z. Now remember, we are going to find x and z first before we can be able to find y, because we solved how we get this x is by using the simultaneous equation involving only x and z. So we need to find z. Then we can now use the value of x and z, substitute in the equation that involves x, y, z, so we can be able to find y. Okay. So using equation 7 to find z, so our equation 7 says 3x plus z equals 9. Alright? So we can subtract 3x from both sides, therefore making z to be 9 minus 3x. Now remember, we subtracted 3x from both sides. I want to make z the subject, alright? So therefore, our z will be equals to 9 minus 3 times, what is our y? What is our x? 3 times x. Our x is 109 over 29. So this is 109 over 29. Of course, we can bring in 29 here as we can bring in 29. We can express 9 as a fraction with 29. How do we do that? By saying that 9 equals 9 times 29 over 29. Because 29 over 29 is 1. 1 times 9 is 9, alright? I just did it because I want to have a fraction that has a denominator of 29. So I can easily add their numerators, picking one of the denominator, right? Because if you're adding or subtracting fraction in such a way that they have the same denominator, of course you can just add the numerator with their signs, use only one of the denominator, okay? So 9 is something as 9 times 29 over 29. So we can rewrite this as, so 9 can be written as 9 times 29 over 29. So let's use, make use of calculator here. So here we have that 9 times 29 is 261. 261. So we can replace 9 with 261 over 9. Now if you divide 269 by 29, sorry, because this is okay, let me do it this way so that there won't be confusion. So this is 9 into 29 over 29. Alright? Then minus, we can open bracket here. 3 times 9 is 18. We have 8 carry 1. 3 times 0 is 0, so I have 1. 3 times 1 is 3. So 318 over 29. So of course, 29 over 29 is 1. 1 times 9 is 9. So if we do this, we have that z will be 9 times 29. We already done that. 9 times 29, we already done that, which is 261, right? So I have 261 all over 29 minus 318 over 29. Okay, now 261 divided by 29 will give you 9, so which is still correct. Okay, so here we can easily subtract and pick one of the denominator, right? So we have 261 minus 318 all over 29. Okay, so at the end of the day we have that z will be equals to 261 minus 318. I think it should be minus 66 over 29. Yes, if we say 318 minus 261, sorry, sorry, I think something is wrong. So have 261 minus 318 7. Okay. 109 times 3. Okay, there's an error here. Sorry. 3 times 9 is not 18. 3 times 9 is 27. Alright? So we have 7 here. We carry 2. 3 times 0 is 0. We put 2 here. 3 times 1 is 3. So this is supposed to be 327. 327. Yes. So here we have 327. 327. Okay? Sorry for the error. So here we have 327. Okay? So we have 327 minus 261. So if we subtract 7 minus 1 should be 6. We carry 1 here, 12. 12 minus 6 should be 6. 2 minus 2 is 0. So 0 66 is 66, alright? So, and you know that the bigger number is negative, so our answer should be negative, alright? So if we do that, we are left with z equals minus 66 over 29. So we can use any of the equations to find z. So we can use equation 3, alright? So using equation 3, to find y. So our equation 3 says x plus 3y minus z equals 11. So at this point we can leave 3z here and take everything outside. So here we have 3y. Sorry, we can leave 3y here and take everything outside. We already have 11 here, right? To remove plus x here, we use minus x. So in other words, x crosses over half minus x. To remove minus z here, we need plus z. So in other words, if minus z crosses over, become plus z. Alright? So remember, minus z crosses over plus z, plus x crosses over minus x, right? So at the end of the day, we have that 3y will be equals to 11 minus our x. Our x is 109 over 29 plus our z is minus 66 over 29. Okay, so we can make this is 3y equals, we can make 11 to be 29 over 29. So we can make it to have a fraction with denominator of 29. So we can easily add the numerators. Alright, so minus 109 over 29 plus times minus 66 over 29. So which is 3y will be equals to, of course, 11 times 29 should be 2 and 9. So 11 times 2 plus 9 is 11. So we carry 1. So we carry 1 and put it, it should be 319. So 11 times 29 should be 319 over 29. Then minus 109 over 29 minus 66 over 29. So if we do that, we'll be left with 319 minus 109 minus 66 all over. We pick one of the denominator, right? So we add their numerators. The signs they have here is negative. So we have 319 minus 109 minus 66 over 29. Alright? So if we do that, we have that 3y will be equals to, so we do the subtraction. So we have 319 minus 109, then minus 66. So the answer is 144. So we have 144 over 29. Now remember, we divide both sides by 29. By 3, coefficient of y here. So if we do that, this implies that 3y over 3 will be equals to 144 over 3 times 29. Remember, somebody will say, where did I go this 3 times 29? We already have 29 in the denominator, so I just divide both sides by 3. So as I divide here by 3, I also divide here by 3. Or I can say multiply both sides by 1 over 3. So if I times here by 1 over 3, I also times here by 1 over 3. So if I do that, we have 1 times 3 is 3y. 1 times 3y is 3y over 3. Then 1 times 44 over 29. 1 times 44 is 44. And 3 times 29 is 3 times 29. Okay? So that you will not be confused with what I did here. So 3 cancel out to 3. 3 here, 1. 3 divide 14. We have 12 inside 14. 3 divide 12 is 4. Remaining 2. We carry that 2 here, 24. 3 divide 24 is 8. Alright? 3 divide 24 is 8. Because 8 times 3 is 24. Okay? So we are left with, therefore, our y will be equals to 48 over 29. Okay? 48 over 29. So now, hence, our x is equals to 109 over 29. Our y is equals to 48 over 29. And our z is equals to minus 66 over 29. So we can confirm the accuracy of our answer by using this value, maybe here. So we can use it, the one that has 3 in a row, or we can test it in all of them. So if we test it on this one, we test it on the middle one. Okay, am I free to clean? Alright. So if we test it here on the middle one, here we have 2 into x. What's our x? 109 over 29. Okay? Plus 2 into y. What is y? Y is 48 over 29. Plus 3 into z. What is z? Z is minus 66 over 29. So if we do that, we have that this will be equals to 2 times 109. 2 times 9 is 18, we carry 1, times 0, 0, we have 1, 2 times 1 is 2, so it will be 218 over 29 plus 2 times 48, 2 times 8 is 16, carry 1, 2 times 4 is 8, plus 1, 9, 96 over 29, plus times minus is minus, 3 times 6 is 18, we carry 1, 3 times 6 18 plus 1, we have 19. Okay, so 198 over 29. So this will be equals to, so we're going to add the entire number. So we have 218 plus 198 plus 96. Alright? Alright? Okay, so we add the entire numerator. So this is 8 plus 8, 16, 16 plus 6, we have 22. Yeah, 16 plus 6 is 22. So we have 2, we carry 2 here. So 2 plus 1, 3, 3 plus 9 is 12. Then 12 plus 9, 12 plus 9 is 21. Okay? It's 21 because if we carry 7, if we carry 8 from here and put it in 12, we have 20. Then plus extra 1 that make it 9. Okay, so we have 21. We can write 1 and carry 2 here, because 2 plus 2 here is 4 plus 1 5. Right? So we can confirm it on calculator. So here we have 218 plus 198 198. Okay. And plus 96. So we are left with 512. So at this point we have 512 divided by Okay, remember we summed everything, which is 218 plus 96 and minus 198 all over. We'll pick one of the denominator, 29, which is 5112 divided by 29. So the punch 5112 divided by 29. Sorry, we didn't get the same 4. So let's confirm a value to make sure that there is no error in our calculations. It seems there is error here, so let's confirm. This is 2 times 109, so I have 218. Okay, so 48 by 2, 48 by 2, 96, and 66 by 3. I have 198, right? So if we add them, so we left with 218 plus 96 and plus 198 is 5112 divided by 29. We're supposed to, maybe I'm coming, let me confirm some stuff. Okay, I found out our error here. I added everything which is not supposed, right? I added everything. I didn't calculate this, I added everything, that's why. Sorry for my error. So I have 218 plus 96 minus 198. Yeah, minus 198. So it should be 116, okay? It should be 116, sorry. 116. So 116 divided by 29. We have minus here, but I'm adding everything, but it's not true. So we have minus, so we're subtracting this plus this minus this. So 116 divided by 29, it should be 4. Yes, it should be 4. So you see that this is the accurate value. So when we add all this, it will be equals to 4. This is this, this is this, and this is this. So when we add all of them, it should give us 4. Now you can try the rest. At this point, you have a good day. Thank you.